Hello everyone, I'm Vlad from Thought Machine, and what I will go through in this lightning talk is how we used abstraction and automation of generating virtual services to build more reliable gRPC services inside the service mesh. gRPC calls inside the mesh fail for a variety of reasons, be it network flakes, timeouts, breaching message limits, server errors, and so on. And nowadays everyone is preaching fail fast and retry quickly. And this is great advice to follow when trying to reduce the highest response percentiles of an API, and oftentimes timing out quickly and doing a fast retry or simply retrying on a transient error will help a request succeed immediately. But when making a request against another service, how fast is a fast fail? If the timeout is too strict, then a request will be killed that otherwise would have succeeded if given a few more milliseconds. But if it's very relaxed timeout, then the calling client might be hanging for too long, and that would stop it from retrying in case of a failure. Or if we look at the bigger picture of your architecture, it could be the same as not placing any timeout constraints at all. So awareness of the service SLAs and SLOs is always needed. And when retrying, is it useful to retry at all? What errors are classified as transient for the specific service? Is it safe to retry, for example, an internal server error? Or is the endpoint in use idempotent? The people who can answer these questions are obviously the service owners. The people who build that API know its SLAs and SLOs the best. And even if there is immaculate documentation across the organization and everyone is aware what to expect of each endpoint, there's still another problem. Retries and timeouts are not happening in the same way for all languages. So we want to have a language agnostic way of doing them that will happen transparently for the service. So Istio's virtual services can be the solution for the problems outlined in the previous slide. Everything will happen transparently for the calling service in a language agnostic way, and the service owners will be able to define the retries and timeouts per service per RPC. However, this brings other problems. The developers now must have knowledge around Istio and virtual services, and also there is a potential for making typing errors that can be easily missed during a PR review. And while the problem with the indentation errors in YAML can be easily solved by using an auto-formatter or a linter, there is still need to protect from simply misspelling the path for an endpoint. And furthermore, the virtual service config must be updated after every change when adding a new endpoint, or in a rare case, change the name of an endpoint. We can use tests to guard against all of this and validate a virtual service entry exists for each endpoint of the service and the timeouts and retry parameters are correctly enforced. Otherwise, it will be hard to find out that a virtual service config applied in the cluster is not correct. And even then, all of this will become hard to manage in bigger services with a large number of endpoints. And the problem does not become easier to solve when having to manage hundreds of services in the cluster. So we asked ourselves, how can we solve everything from automatically generating the correct path, so we don't have to worry about typing errors, to validating the virtual service without the need to have tests for each endpoint, to what is the best place for a developer to set these parameters per service per RPC without having to worry about Istio at all. And in Thought Machine we use proto files to define our gRPC services, and we therefore created an API using proto annotations, which allows all developers to specify the timeouts and retries individually for each endpoint inside the proto where the gRPC service is defined. And also from here we can easily generate the path by concatenating the package, service and method names while parsing the proto to get the timeout and retry annotations. And you can see an example how the API would look like from an application developer point of view when defining the timeouts and retries for the greeting gRPC service example on the right. And furthermore, if we want to, we can also overwrite the retriable error codes for that endpoint, and let's say we can only retry on an unavailable response. And we integrated that with Please, our open source build system, which allows for creation of miscellaneous rules that can be executed during build time and help us auto-generate the virtual service. An example for such a rule is the Kate's manifest rule used for templating and auto-generating manifests, which has a quirk called gRPC services that accepts the build target for the gRPC proto, and by passing the deployment and service YAMLs, which contain additional information like gRPC port, host name, and so on, we can create a small binary tool which auto-generates the virtual service config for our greeter Kate service that serves the greeting gRPC service from the previous example. And we can also easily extend our binary to automate the execution of commands like IstioCon validate and IstioCon analyze to test the virtual service before outputting it. And that way, if we have in the meantime, let's say, upgraded our Istio version and there has been a non-backwards compatible change that has slipped through and we have missed while reading the docs for any changes before upgrading the version, we would find that our virtual service is not compatible with the new API earlier when running our integration tests before everything gets deployed in a real cluster. After building the virtual service rule for the greeting service, we can see the output of the binary, which extracts the proto annotation and appends them to auto-generate a virtual service config. And then we can easily bootstrap this process by using Please to auto-deploy our services inside the Kate cluster and apply the virtual service and other manifests generated during build time. And that's how we automatically created a virtual service for our greeter service example. And to recap, we have created an API which gives us a scalable way to manage all the configs inside the cluster as they now become a release artifact for the given service, and therefore it makes the life of the service mesh owners in the organization easier. And at the same time, application developers have an easy abstraction for defining SLAs and SLOs for their services and use virtual services to enforce these without knowing about Istio at all. Thank you for your time.